laptop company. And that's actually true. We are the laptop company. We're also the desktop company, workstation company, and one very large enterprise computing company. Many data centers will have a lot of Dell hardware in them. And that's true also in the automotive industry. And in fact, if we just look at today's topic, which is autonomous driving development, or ADAS/AD, that happens to be an area where we have quite a significant amount of hardware that's present at our customers. And we estimate about 70% of sensor data that's collected by the tier one suppliers, particularly in Europe, resides on our storage as an example. And of course, going with any one of these projects, you also will have servers, GPU servers, networking, other types of storage, services to go with all of that. So we actually have quite a lot of experience in this market, and that's part of the reason why we are here today. And with autonomous driving, those of you that are already active on a project definitely would know this, is that it's quite a complex flow. There are a lot of different tools that are required, and it can be quite overwhelming, especially for a startup where they don't have an established tool flow or data flow, most importantly, in place. And what you see here is the AI, what we would consider to be the areas that your data scientists would normally be focusing their time. But remember, today's topic is about AI, and autonomous driving, it's all about AI. And so in the ideal world, your data scientists, which are in shortage, would be focusing on only these two areas in terms of the overall data and tool lifespan of your project. Unfortunately, what we found through talking to so many customers is that the data scientists are actually spending a lot of their time doing non-data science work, which is particularly frustrating because, remember, I mentioned data scientists are in relatively short supply, which means they're also quite expensive compared to many other engineering disciplines. So you really want to figure out whatever you can do to be sure that they're spending their time doing what they do best, which is algorithm development. So we actually did a survey. We sponsored a survey with Ward's Automotive, and that actually confirmed what we had observed in the industry, which is about 70% of the data scientist's time is spent doing things that have nothing to really do with AI, like trying to identify tools, trying to get tools to talk to each other, trying to figure out how to get, enriching your data, getting data labeling working, all kinds of things. And so Dell, what we chose to do was to try and help our customers by identifying all the partners that are out there that are specializing in different areas and mapping them to this tool flow for autonomous driving specifically. And so you'll see that there are tools here for Hill and SIL and for data ingest and for orchestration and multi-cloud and a whole variety of others. And today we're actually showcasing one of our key partners, which would be Acrodata. And what we really like about Acrodata is that their tools span the data flow for autonomous driving from edge to core to cloud. For example, they have the ability to set up in-car data analysis, for example, to do pre-labeling. They can also do that and more at the edge. Another example would be identifying important data and raising the priority of that and making engineers aware that it's been collected because it might be something that they're critically looking for. They can do orchestration across the entire tool flow. Very important to be able to use many of these different automation tools and yet get them to talk to each other. Can be a major challenge. And then, particularly for those projects that have collected a lot of data and maybe it's not been labeled as well as you would like, they're going to be talking about some brand new technology that they just came out with that will make it very easy to rapidly analyze a large data set and make it very easy for the data scientists to be able to identify those critical corner cases or scenarios of data that they would like to use for testing. So with that, I'm going to hand it over to Kunal. Kunal?
Okay, thank you, Larry. And hello, everyone. I'm Kunal Vasavde from Accredited. In today's webinar, I'm going to focus on how to kind of do unstructured data exploration and analysis using the capabilities that we have developed, leveraging Dell ecosystem of infrastructure and tools as well. And let's dig right in. So AI and ML development in 2022, where all of us are expecting better, ADAS and AV features, and our expectation is rising every day. Behind the scene, companies are trying to accelerate their program timelines and provide these cool new features with appropriate safety and scale, and all of that begins the journey at the data level. And more and more AI use cases now taking this data-centric approach, where if you get your data done right, your algorithm performance and overall feature application development time reduces quite a bit. And today I'll talk more about that as well. Larry already kind of talked about the problem, and newer ADAS and AD development data needs are shooting to the roof. Amount of data that is generated by ODD, FOT, and development vehicles is now reaching into a petabyte a day type of footprint. All of this data is being generated across the globe in various different regions. The processing also is unique in terms of each of these sub-programs, and there are a plethora of proprietary formats, tools, data pipeline code, and all of that have to be managed in a more structured, standardized manner for the programs to scale from IT cost and innovation point of view. So we at Accredita saw the problem as a need for an extensible integration framework where pre-existing and new code, pre-existing infrastructure as well as the new infrastructure, and the overall hybrid processes of different business units all have to be encompassed into a common place where data problems are solved in a more global manner. As data is becoming more of an enterprise resource, standardization is something companies cannot delay further. At the same time, they cannot put brakes on innovation and collaboration side. So hybrid everything is the nature of the problem, where how do we support teams, infrastructure, data campaigns, and multiple different partners and vendors coming together to solve the problem. The solution that we have developed at the highest level allows customer to run customized data campaign starting at the edge where most of the new data is being generated, apply their own data filtering logic in a standardized, usable manner at the edge to reduce the amount of data that needs to be passed on to the AV and AI developers by essentially factor of 90% reduction, and make that data available quickly while rest of the data remains with them and then slowly trickles into the larger data center footprint and public cloud ecosystem. So by giving a customer a control over what data needs to be processed when, what data needs to flow into which infrastructure tier, and do all of that in a configuration manner so that each program can have its own sovereignty, while at the corporate level you can drive a standardization effort. So our capabilities around deploying these data processing nodes that can be deployed across the edge public data center and private data centers. You can run those recipes, configure your priorities, and then transfer. For image and video data, along with doing this processing, you could also do a more interactive human-in-the-loop exploration to again reduce the amount of frames or edge cases that are hard to find in a fairly large amount of video and image data, and find those in a matter of minutes. Then I'll focus on 3 problems and a quick solution in the interest of time. The very first one is, how do you keep up with the scale of incoming data? Capture, ingest, curate, and tag at the near source, develop context and metadata, and then use that to define your upward journey for your data flow. Second is around people and processes. How do you drive a unification and standardization across your entire organization while maintaining or increasing the overall developer experience? And the third part is around how do we do unstructured data exploration and analysis for video and image type of data sets. So, for data ingest, the reality is each company would have a fairly complex set of sensors with a lot of proprietary IP, and that data, when it comes back from a drive, 10 to 12 hour worth of data could easily hit 10 plus terabytes, and in newer programs it could be 20 to 30 terabytes for a single car drive. Under the hood, and sorry for the eye chart, but what I'm trying to demonstrate is that multi-sensor data with proprietary nature is fairly complex, that idea of processing that at the source sometimes feels far-fetched. But if you look at underneath, it's more about how do I get multiple different sensor streams aligned, ingest it in a way that they are chunked. Each substream of the sensor goes through their own processing pipeline, and each of them can have a different programming language needs. Certain sensors are better processed with GPU, others are okay with CPU. How do you kind of stitch together a flow where each of the sensors get their appropriate runtimes and underneath infrastructure slices, while overall at the data campaign level, you are able to look at, ingest, pre-processing, quality check, relevance evaluation, and then ultimately identify a smaller data set from that full day worth of drive where the interesting things happen, like animal crossing the vehicle, or vehicle got a brief disengagement. Those type of scenarios are more important to the AV engineers and AI engineers. Those are the ones you can identify and then determine where you want to transfer that data at what rate and pace. So this is an eye chart to kind of demonstrate what happens. The case in point with the Accredata capability on Dell infrastructure, this is one case where with a relatively standard 1 Gbps line, how do you get about 50 terabytes of data captured in 60 hours? However, kind of flowing the entire data as a fact by copy with Accredata filter framework and exploration capabilities, within 3 hours you can start ingesting all of the raw sensor data, start processing them on Dell PowerEdge servers. 1 or 2 servers with a single GPU would be sufficient for this type of a use case. Identify substream of data through your logic running in a standard manner, deployed from cloud to the edge devices. And by the third hour, you would start getting early data bits available with its context captured in the metadata catalog and pushed to the database where AV and AI engineers can take a look at it and start browsing and start making use of that data. By the 5-hour mark, you can get top 2% of the data transferred to your core data center or the cloud, and then the rest of the data would continue to flow via physical or a network transfer to cloud, and in 60 hours or so, you can get all of the data. So key idea here is knowing what's in your data within hours as opposed to day. You're using the data context or the metadata for identifying data transfer controls and uploads. And overall, you are shifting left in terms of data processing, where every drive across multiple vehicles, now you're able to capture top 2 to 5% data quickly, and then the rest of the data could move in a cost-effective manner to its destination. This is not just an idea. We have deployed this solution along with Dell at the top 3 auto OEM. with about 20 petabytes flown through the system. Idea